Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about trigonometry. Now the question that I've chosen to go through here is 2017 Paper 1 Question 9. Now I just want to highlight a few things here. Notice that trigonometry usually comes up in Paper 2, which means that the students who did their Leaving Cert in 2017 wouldn't have actually revised their trigonometry by the time they got to this exam, which meant that the marking, I think that this question was answered quite badly, and the marking scheme actually reflects that a lot. Even though there's only 40 marks for this question, 20 of the marks were going for Part A. Now, if you've had a look at the marking scheme, you'll notice that the way they do it in the marking scheme is marginally different to the way that I'm doing it here. So I want to just explain to you this is the way that makes most sense to me. And then I want to explain to you the other solution to this question. So I'm given the function a plus b times the cos of ct. And this describes the depth of water as the tide goes up and down. So high tide is 5.5 meters, and I'm told that low tide is 1.7 meters. So my y-axis should be clearly labeled as the depth of water in meters. The y-axis, I think it's relatively straightforward. I think it's easy enough to label that one. But there's a lot that, along my x-axis here, I think this is really important, okay? You've always learned that a cos graph always starts at the top. So a cos graph always starts at its maximum. And because that's the way I always teach it, I think it's easier to understand this one if we draw it like this. Again, you'll notice that this is slightly different to the way they have it in the marking scheme. If you draw it that a line is going through P and that that P goes through the y-axis, well, in that case, I want you to notice that your x-axis is not the time of day. Okay? It tells me that high tide occurs at 2 a.m. High tide, or in other words, P, is at 2 a.m., which means that this, when my x is 0, that's 2 a.m., which means that my x-axis is not the time of day. The x-axis is the hours since high tide. So for me, this was the best way to solve this question. You label your x-axis as the hours since high tide. So the 2 here represents 2 hours since high tide. Since high tide was at 2 a.m., that means when I'm marking in 2 hours since high tide, that's actually 4 a.m. 4 hours since high tide, this is 6 a.m. This is 8 a.m., 10 a.m., 12 a.m. So I want you to notice the 12 here actually is 2 o'clock in the afternoon, or 1400 on the 24-hour clock. And I was told the second high tide is at 12:34. So in this case, my about 12:34 should be where my other high tide is. So just, for me, that's the best way to answer that question. And you were given the marks for that. In the marking scheme, they said that you were allowed to do it like that. Let me just explain to you the way that it is done in the marking scheme. So for me, that's the way you should have answered that question, where the x-axis is not the time of day, it's the hours since high tide. In which case, the second maximum should be at about 12:34, which that means 12 hours and 34 minutes after the first high tide, which is actually 14:34. However, the other way of doing this, just if you don't like that way, let me show you the other way of doing it. So the other way that you could have done it is you could have had your, let me just write, so if, let's say I completely get rid of this. The other way you could have done this is you could have changed your x-axis and your y-axis, and you could have had your y-axis here, and you could have had your x-axis as the time of day. Okay, so my other solution to this is I could have said that, right, this is midnight and high tide occurs at 2 o'clock, and then this is 4, 6, and I label it the whole way along. And the key then would be that my second high tide occurs at 14:34. Okay, so that would have been the key there. The top here would have been 5.5 and the bottom would have been 1.7. But I don't like that way. And the reason I don't like it like that is because it's contradictory to everything you would have learned about a cos graph. The way we learn cos graphs is that a cos graph, we always start off at the maximum. Whereas if we do it like this, we're not starting off at the maximum, which I think just confuses the matter a little bit. So This is the way that the marking scheme accepts. This is the way it's drawn out in the marking scheme. However, notice at the very end of the marking scheme, it does say that it's acceptable for P to go through your y-axis. But that only makes sense if you label your x-axis as the hours since high tide, as opposed to the time of day. So I just want to stress, so again, if you're not sure of that, send me an email or ask me in class, and I just hope I've clarified that for you. I think the fact that the marking scheme explains it like this, for me, certainly, I think if you were in an exam in the Leaving Cert, you probably would have, your inclination would probably have done it to do it the way that I did it first. But the key there is label your x-axis accurately. Now, let's move on now and talk about part B of this question. Part B, you'll notice I've just drawn a really rough sketch here. Part B, I'm looking for A and B. And in order to get A and B, I'm going to use I know the max is 5.5 and the minimum is 1.7, which is going to make life very easy to find my A and my B. A is the midline, okay? So the midline is essentially what I'm talking about is this line here. The midline is the line that's halfway between the maximum and the minimum. Or in other words, the average of the maximum and the minimum. So to get the average of 5.5 plus 1.7 divided by 2, the average of these two works out as 3.6. Which means that I can say the midline of my cost graph is 3.6. So the average of my max and my min is 3.6. And that's my A, so that's my first answer. The question also asked me to find my B. Now B is, I often refer to it as the amplitude. Okay, so how far does the range of values, basically how far from 3.6 does the graph deviate? The amplitude is the difference between the maximum and the midline, or the difference between the midline and the minimum. So it doesn't matter either way. So let's say the maximum minus the midline, the range or the amplitude in this case is 1.9. 5.5 minus 3.6 gives me 1.9. So that means I know that my A is 3.6, which is my midline. My amplitude is 1.9. In other words, it goes up 1.9, then it goes down 1.9, and then up 1.9, and then down 1.9. Okay, so that's my A and my B for that question. Part C of this question says to show that C is equal to 0.5 correct to 1 decimal place. Okay, so I know my function f of t is 3.6 plus 1.9 times the cos of ct. And ct is in radians. In the start of the question it told me ct is in radians. Hasn't been relevant up until this point. Now you should know that the coefficient or the number in front of my variable in the brackets here has something to do with the period of my function. So we have a formula for this. For a cos graph or a sine graph or any of these trig graphs, the period is equal to 2 pi divided by the coefficient of t, or the coefficient of the variable. In this case, c. So I know the period is equal to 2 pi over c. And remember in the question they told me what the period is. I know the first high tide occurs at 2 o'clock. The second high tide occurs at 14:34. So the difference between high tides is 12 hours and 34 minutes. So that means I know the period of my graph, the time it takes to get from the maximum down to the minimum and back to the maximum is 12 hours and 34 minutes. So I know my period. But obviously I don't want to sub in 12 hours and 34 minutes into this. I need to write it as 12 point something hours. So I need to write it as a decimal. So the easiest way to do that, I need to convert my 34 minutes into a decimal. So to do that, you just take the minutes, you take your 34 minutes and you divide it by 60. And if you do that, you get 0.56 recurring. Which if we round that one off, that means that 34 minutes is equivalent to 0.57 hours. So if I round that off, it's 0.57 hours. Which means that I know my period is 12.57 hours. Or in other words, 12 hours and 34 minutes. So I know that 12.57 is equal to 2 pi divided by c. Now all of a sudden I've got one equation, one unknown. It's going to be relatively straightforward to find my c. But just the important thing here is I'm starting to deal with a pi, which means I have to take into account that ct is in radians. So my calculator has to be in radians to get the answer here. I suppose the first thing I would do to get rid of my fraction is I'd multiply both sides by c. and I'd get 12.57 C. 12.57 C is equal to 2 pi. And now obviously I want to get C on its own, so I'm going to divide both sides by 12.57, which means I get C is equal to 2 pi over 12.57. And if you plug that into your calculator to one decimal place, you get 0.5. And the question was to prove or to show that C is equal to 0.5. So I've proven what they asked me to do. So I just do a little conclusion. Put a tick beside it and say that it's true. So always if you show something or you're asked to prove something or verify something, just a tiny little conclusion at the end. For part C of this question, we're asked to use the function f of t in order to find the times that afternoon when the depth of water in the harbour was 5.2 meters. Remember, the depth of water is given as our f of t. So they're telling me that f of t is equal to 5.2. So I can sub into my function, except instead of an f of t, I can sub in 5.2. Which means that I can say that 5.2 is equal to 3.6 plus 1.9 times the cos of 0.5 t. So clearly, if I've got one equation, one unknown, so if I work my way through this question, I'll solve it to find t. And that's going to tell me the time of day that the depth of water in the harbour is 5.2 meters. So the first thing I want to do is I want to get my 3.6 out of there, out of the right hand side. So in other words, I'm going to subtract 3.6 from both sides. So I'll get 5.2 minus 3.6 is equal to 1.9 times the cos of 0.5 t. 5.2 minus 3.6 is 1.6. And on this line, I want to try and isolate my cos 0.5 t, which means that rather than multiplying by 1.9, I'm going to divide both sides by 1.9, which means it becomes 1.6 divided by 1.9 is equal to the cos of 0.5 times t. Now I want to continue this further, and I want to isolate my 0.5 t, which means on the right hand side I'm just going to be left with 0.5 t. And on the left hand side it becomes cos inverse. So it's cos inverse of 1.6 over 1.9. And now now I want to isolate my t, which means I want to divide both sides by 0.5. So it's going to be the cos inverse of 1.6 divided by 1.9, and all of that divided by 0.5. Now if you plug all of this into your calculator, you're going to end up with t is equal to 1.139 hours. Now obviously we don't want this in 1 point something hours, we need it in hours and minutes. Which means if you press your DMS button or your degrees, minutes and seconds button on your calculator, it will straight away convert 1.139 hours into 1 hour and 39 minutes. Sorry, 1 hour and 8 minutes. So 0.139 is equivalent to 8 minutes. If that's not working for you on your calculator, there's another way of doing it. You can just take the decimal, just the decimal 0.139, and multiply it by 60. If you get 0.139 and multiply it by 60, it'll tell you that to the nearest minute it's 8 minutes. So I know that when t is equal to 1 hour and 8 minutes, the depth of water is 5.2 meters. You have to pay attention to what t actually represents. Remember, in the start of the question, it told me that t is the time since high tide. And I've been asked for the times in the afternoon when this is true. So let's look back at our graph. I know that high tide occurs at 14:34, or in other words at 2:30. Now clearly this is the afternoon. And I know that 1 hour and 8 minutes after this, which is roughly somewhere around here, I know that at this point the depth of water in the harbour is 5.2 meters. That's one of my answers. But clearly this is a perfectly symmetrical graph, which means that if it's 5.2 meters an hour and 8 minutes after high tide, then it's also 5.2 meters an hour and 8 minutes before high tide, which means that my other answer is going to be here. So that means the times in the afternoon when the depth of water in the harbour is 5.2 meters will be the high tide, which was at 14:34, and then I'm going to add on 1 hour and 8 minutes. So 14:34 plus 1 hour and 8 minutes gives me 15:42. Okay, so now just be careful. Notice I'm putting 2 dots there to symbolize I'm using the 24-hour clock. That's not 1.08, that's 1 hour and 8 minutes. It's not 15.42, it's 15 hours and 42 minutes. So the first answer, or in other words, this one, at 15:42, the depth of water in the harbour is 5.2 meters. To get the other answer, it's the high tide minus an hour and 8 minutes. So in this case, it's 14:34 minus 1:08. So I've got 14 hours and 34 minutes minus 1 hour and 8 minutes, which in this case gives me 13:26. So my second answer in this case is that at 26 minutes past 1, or 13:26, the depth of water in the harbour is 5.2 meters. So again, I hope this video made sense. I think it's worth your while. Have a look at the way the marks were distributed in that question, because the first part of the question actually held 20 marks. I think the marking scheme was relatively skewed in this question. If you had any problems with any of that, then just let me know in class or send me an email and I'll try and explain it differently.